Hello everyone, welcome to JPJC Open House. I'm Mr. Pang Kang Ming. I'm the HOD for Physics and Biology, and I teach physics in JPJC. I am sure you have heard about physics before. Some people say it's hard. Other people say you have to study it if you want to become an engineer or a doctor. But physics is way simpler than you might think. The word physics comes from the Greek word physis, which means nature, and physik, which means knowledge of nature. So it is really about nature and the things around us and how those things around us work that we are really studying. So what kind of things is studied in physics? You will study energy for one, force, motion, and electromagnetic radiation, which you commonly call it light. You will also study how matter moves through space and time, and how force and energy affects that motion. What we study in physics is to try to discover how exactly the universe works. Now, physics is one of the oldest academic disciplines. Nearly all civilizations have some form of physics. It is the way we understand our world in a very scientific manner. But what relevance does it have to other subjects? Well, both chemistry and biology rely on the laws of physics in order to perform calculations and sense-making of the discovery. So why physics? A-level physics provides an excellent preparation for a university course, not just in physics, but in all engineering and computer science disciplines, in life sciences, including molecular biology, genetics, neurobiology, in earth and atmospheric and oceanic sciences, in finance and economics, and in public policy and journalism. You name it, there is physics. So physics encourages quantitative, analytical, and big picture thinking, which is very essential in the 21st century critical thinking. Why is physics important then? Besides what we have mentioned before, physics impact our daily lives. Smartphones, tablets, and computers, which you can't live without, were created by following the laws of physics that study electricity. Motor cars that you see on our roads were invented when physicists discovered how to convert fuel into kinetic energy to get the car moving. This is also how many other useful inventions and machines were created. For example, in medical care, machines such as X-ray, MRI, and ultrasound were created by studying the principle of waves, light, and electricity. In fact, when you look at any human invention, you will see the influence of physics. So, who can study A-level physics? Well, anyone who has studied O-level physics, who has studied combined science where physics is a component of that study, you can study physics. And the university courses that are relevant to physics, the list you can see up there. So many of them, all the way from engineering discipline, all the way to health sciences, and of course to many areas which makes important impacts in our daily lives. What does it take to do well in physics? Passion for one, aptitude in the subject, but I would say most importantly, the attitude towards learning. So let's spend a minute to talk about H1 versus H2, whether H1 physics or H2 physics. Now, what you see down here in H2 physics is the total number of topics in H2 physics, all the way from topic 1 to topic 20. Those topics in red are the ones that the new ones that you're going to study in A-level physics, such as motion in a circle, gravitational field, first law of thermodynamics, superposition, electric fields, electromagnetic induction, quantum physics, and nuclear physics. Now, that being said, those topics that you have studied in O-level will go deeper in A-level. And here's a look for the H1 physics, 10 topics, for those new, motion in the circle and orbits, as well as nuclear physics. But for all the other topics, we'll go a little bit deeper than O-level. So studying physics is not just about studying the theory and doing the question after questions. We have fun with physics in classes as well. For example, we use the air piston to demonstrate the effects of energy transfer in thermal physics in classroom. Oh! There you have it. You will see that when you come to our class. And of course, we'll use the ripple tank to demonstrate to teach the overlapping of waves. So what you can see down here is a wave that's been disturbed. When you project it with the light, you can see that the waves does interfere with another wave. And of course, we'll do station rotationally in our practical lessons, where you'll be doing work solo as well as in groups to discover new phenomena in physics, such as this one.
Put it in perspective, what we need to do today, very simple. First part, recap the prior knowledge and apply the learned concept to today's. You do the entry quiz first. So 3 stations, entry quiz, solo, practical task, groups of 3, only are true. Please observe SMM. Then finally, after you finish then we go for the exit quiz.
Okay, there you have it. So quite intense lessons in physics, with demonstrations, with practical lessons, with group and solo work. Of course, we have enrichment activities that covers enrichment talks by professor from NUS during STEM week. We also bring our students to NUS labs to show the effects of superconductivity and even quantum physics. And some of our students here participate in the Singapore Science and Engineering Fair. And of course, we have our very own annual STEM day, where our students worked to explain how science works to fellow students in our college. Our students do take up NUS modules and study during the June holiday period, like what you see down here. Our students taking electrical and computing engineering modules, and our students are also facilitators in VIA programs to younger students from De La Salle School. Of course, our students did take part in the SUTD Electric Vehicle Design Challenge, where they come together to build a electric vehicle from scratch. So that was very exciting. Our students also took part in the Engineering Innovation Challenge, where they actually use a live radioactive source to investigate the growth of food crops, and thereby winning a merit award in that challenge. Our students also want honorable mentions at the Singapore Physics Olympia, and that's important to us because it's the first time we have so many students winning in a single year. So expectations for physics. Well, we do expect you to be independent and self-directed learners. There will be such learning going on, and we hope that you'll be proactive and participate in class discussion. And more importantly, always come prepared for lessons. Ask questions to clarify doubts as soon as possible, and of course, be curious. Be curious. So begin with the end in mind. If you intend to study physics, be mindful of the university admission criteria that requires H1 or H2 physics at A level. Now, physics at A level is more rigorous than that at O level. I won't lie to you. Now, doing well at O level physics does not guarantee good results at A level physics. You have to put in effort in order to succeed. So begin with the end in mind. Having the right attitude, right aptitude towards learning will set you on good track in getting good results in A-level subjects, A-level examination, not just for physics, but for any other subjects. And the feel for physics, I must emphasize, some students tell me that they have no feel for physics, but the feel for physics can be developed over time, provided you strive and work hard towards your goal. So in conclusion, should you take physics? Should I take H1 or H2 physics? The answer lies in yourself, the passion, your aptitude, then your attitude, and your further plans for further studies and even career options. That you have to decide yourself. So these are some useful websites where you can get information on the syllabus of H2 and H1 physics, subject combinations for JP, JC, and as well, of course, university courses. You can go to the respective university websites and look at what is required in order to take up the course in the university level. So with that, I thank you very much for your attention, and I look forward to seeing you at JPJC. Thank you. Goodbye.